All right, so now we're going to do. Oh, that's weird. It's kind of annoying. Okay, so now we're doing part C. After adding 12.5 mils of 0.3 molar NaOH. Now hold on. This is a special case, as you will see soon enough. So why is this a special case? Well, before I can tell you that, you need to figure out what is the volume that you need of the base for equivalence points. So how do you figure that out? Well, equivalence point was when the moles of the acid are equal to the moles of the base. So the moles of the acid are 7.5 times 10 to the negative 3. Uh, if you don't understand how I got that, all I did was the concentration times the volume of HF, and you'll get this number. Now, since the moles of the acid are equal to the moles of the base, well, moles of the base are equal to this. So our original goal was to find out the volume of the base needed for equivalence point. So we know the moles of the base, because it's the same as the acid, and we know the concentration of the base, because that's always given. So what's the volume? Well, volume is equal to moles over concentration. Moles were 7.5 times 10 to the negative 3. Concentration was 0.3. Do the division, you get 0.025 liters or 25 mils. So 25 mils is the volume needed for equivalence point. So now we're actually adding 12.5. Now, what's so special about that? Well, actually, equivalence point is 25, so we are adding exactly half of the equivalence point. So for example, if the equivalence point was 30 and the part C was, let's add 15 mils, then this is also a special case, because the special case occurs whenever you're adding half of the equivalence point. This makes the calculation very easy, and this is pretty much anyone can get this. So whenever you're doing, like, part A is always going to be initial, part B is probably going to be somewhere before equivalence point. There's a possibility that part C might be half of the equivalence point. If it is half of the equivalence point, all you need to do is figure out what the equivalence point is, and then half that, and you know that volume. So in this case, we are adding half the equivalence point. So if you add half the equivalence point, to get pH, all you do is just take the pH negative log of the Ka or Kb if it's a weak base. In this case, it's a weak acid, so you just do the Ka. But if it was a Kb, you take negative log Kb. So try it. In your calculator, do pH equals negative log Ka, negative log of 6.6 times 10 to the negative 4, and you get pH is equal to 3.18. Now if you check the answer, that's actually 100% correct. See, 3.18. So literally, the special case is half of the equivalence point. All you do is negative log Ka, and that's the pH. So literally, that's all you have to do part C, and you'll get full marks because you figured out the pH, and that's what it's asking for, right? Right. Thank you.